I'm on my own, broken and alone. I feel the rain crashing down all around this empty town.
Alright, so we're on a roll today. We got the turbos, injection pump, injectors video done, so let's go ahead and get the wiring done. This is a image of what the ECU, EDC15, VM Plus, and the actual plugs look like. I know they look very, I won't say confusing, but it looks overwhelming, and to be quite honest, it's not. This is just a reference so you have an idea of what you're dealing with when you get into the meat and potatoes of working on these ECUs. It's actually quite simple. So this is the Excel file that I normally use when I'm making a new harness. I created these from information that I found online. For the most part, everything is correct, although the wires could sometimes be a little bit different. But for the most part, all you have to do is look at the pin, figure out what the wire color is, and kind of go from there. This is, of course, everything that I have as far as these four harnesses: the early ALH, the late ALH, the BHW, and the BEW. Although, to be quite honest, I have not worked on these before, so I don't know exactly what is needed and what's not needed. Your best bet for that is to talk with your tuner and then kind of go from there. So back on the ALH. Again, it seems overwhelming, but to be quite honest, it is not. Everything that is green on the left-hand side is a loose wire that you're going to have to deal with. All the whites, for the most part, are already part of the harness that comes out of the car that you're taking them from, so you don't have to deal with them. The reds can be deleted. The blue is specific to cruise control. What I do want to do is kind of go over every wire that I think might be important so you have an idea of what is going on. So of course, main 12 volt input and the grounds are common sense. You guys should know what that is. The CAN bus high and low are only used if you're going to be accessing CAN, normally with some sort of transmission controller. You cannot do diagnostics on the EDC15 via these two wires. You can only do it via K-line, which is a little bit slower. Hence why when people try to use the OBD2 port to display on gauges, there's a very drastic delay from what the ECU is sending before the gauge actually responds. So in most cases you don't have to leave these wires, you can take them out. In my XJ build I am leaving them in specifically because I have a transmission controller that will get the input signals that it needs from the ECU to be able to control the shift points in the transmission. So glow plug. The glow plug wires themselves, if you want to keep them, then fine. You can actually delete them and have your tuner remove the glow plug information from the ECU. You can just do a momentary push button like I have in the CJ with a forward start solenoid from I think the 50s, 60s, 70s, and 80s. So you can keep that, you can remove it, it's up to you. Throttle pins, you're going to of course have to splice those wires in. Do it appropriately. I suggest heat shrink and solder because the connection from the ECU goes through a bulkhead connector. I think it's the blue housing, but I can't remember off the top of my head. So you're going to have to cut and extend those wires to where you need them. So these are of course important. Cruise control. So there are a couple wires for cruise control. Cruise control on is just, what I do is I just hook it up to ignition 12 volt. If your vehicle comes with cruise control like the XJ does, it's the push button at the end of the stock, at least for mine it is. On my Toyota Tundra it's a push button where you turn the cruise on. So that's all it is. You're turning 12 volts on, the ECU notifies that you turned cruise control on, so it's looking for inputs. Continuing on cruise control, we have the vehicle speed sensor. I have mine connected currently on the CJ to the output housing of the Dana 300. So this is only needed if you need cruise control, if you want cruise control, so that's something you can delete. Technically, all of these you can delete to a point, and we'll cover those. Okay, so there are two brake wires. We have pin 65 and pin 32. Pin 32 sees 0 volts in its normally rest state, and it sees 12 volts when it's actually the pedal is depressed. 65 is the opposite. So what the ECU is looking for is it's looking for 0 volts or open on pin 32, and then pin 65 it sees 12 volts. And whenever you push the brake, those should change at the exact same time. If they don't change at the same time, you will get an error and the cruise control will not work. You can normally do this with a, I think it's called a logic controller that slow backward cells. You could use that, or you can just use a regular automotive relay. I like the idea of using an automotive relay because if it fails, you just pop the relay out, put a new relay in, and you're good to go. Of course, you can get those at the local auto parts store, whereas if you order from slow backwards, it might take a bit for you to get it, and then of course you have to cut and rewire it into the circuit. Cruise control, set, resume, and on are all common sense. I tell you exactly what they are. So that's cruise control. We'll go back. So K-line, again, this goes to the OBD2 port. This is your communication into the ECU. You can do that through VCDS VADCOM. You can also program the EDC15 through this as well. So this is very, very important for you to have. Relay 109 ground. So when the ECU is woken up via pin 37, which is an ignition wire. So ignition wire comes into the ECU, tells it to wake up. This sends a ground to the 109 circuit and actually takes power and sends it to all the items powered by the 109. I normally remove this thing and just make a regular automotive relay setup. So I'm not relying on the ECU to set ground. I'm actually, when I turn the key on, it turns on the fuse, and the fuse turns on the relay, and etc., etc. Okay, check engine light. We'll cover this here a bit more in depth. So the check engine light is technically a ground, but it's an inverted ground. So when you do not have a check engine, when you have a check engine light, and if you just hook it up to ground, you're going to have a light on. If you don't have a check engine light in the ECU, check engine error code, then it'll actually turn off. So what you need to do is you need to create a transistor dual resistor setup and wire it in with all the wiring, and I'll explain that here in a second. Tack wire, again, is common sense. More than likely you're going to need some sort of communication device to take the output signal from the ECU. It takes it from the crank position sensor, and you need to translate it into whatever the vehicle that you're swapping into is looking for. For example, I use a Dakota Digital box. Currently is taking my signal from the crank position sensor because I did have the mechanical injection pump, so I didn't have an ECU. But before that, it was actually the number 27 wire going into the Dakota Digital box, and then the output would go to my tachometer. You can Bluetooth into the device and tell it exactly the parameters, make minute adjustments so that you're showing exactly what the ECU is telling you through VCDS. Alright, so now let's go to the check engine light. So again, this seems overwhelming, but to be quite honest, it's very simple. So what you're going to need is a 2N2222 transistor, and those transistors have 3 legs. There's a collector, there's a base, and there's an emitter. So the emitter section, I solder on a section of wire to ground. I tie into the base with a 3.3 k ohm resistor. I solder those together. Then I have a 6.8 k ohm resistor that comes out. Then I hook that up to another section of wire, and I hooked it up to 12 volts. And then on the collector, it goes to the lamp, and then the lamp goes to 12 volts. With the LED or bulbs, the same thing with the glow plug. If you have LEDs, there's normally not enough resistance for the ECU to know that everything is okay. So you might get some faint glow. If you Google how to fix that, it's quite simple. You basically just take, I think it's a 1K resistor, and you cross that over between both legs, but I don't want to speak on that now. Alright, so we'll go back here. Alright, so check engine light, good. Tack wire, good. AC. You need to trigger AC in your vehicle with 12 volts. You don't need to use the ECU for that. MAF sensor. I delete those, and my tuner actually takes that out of the system. So you would need to speak with your tuner and see if he or she is going to tune you specifically for a MAF delete, or if you need to maintain the MAF. If you don't need to keep it, go ahead and take it out. Intake air temperature sensor, again, it's white, so it's already connected. You don't have to do anything with that. Glow plug relay, we talked about that. Wake up ignition. So we have two of these wires. We have pin 37 and pin 88. Pin 37 being on the bigger plug for the ECU, and pin 88 being on the smaller plug for the ECU. I tie these together, fuse them, and hook them up to ignition. Alternator. Excuse me. There are two alternator wires. On the plug itself that plugs into the alternator, you have pin 1, which is an exciter wire. It needs to see excitation on the field, so it'll actually start producing voltage. Technically, it doesn't need this. If you rev the engine a couple of times, you should see that the alternator should be self-exciting and producing voltage that you need. I always hook this up. I put a little bit of resistance into the wire, and as soon as I start it up, I check my volt gauge and I show that I'm showing, 14 volts, a little bit higher, a little bit lower, depending on the load. Pin 2, that's this one here. This is just the alternator load sense wire into the ECU. In the past, I've wired them up, but come to find out you don't need them. So if you want to hook them up, again, that's the second wire in the plug for the alternator. Hook it up. If not, leave it out. This is the glow plug light. This is the one that's on the dash. It shows a little squiggly. This is a ground circuit. So when the key kicks on, or when the glow plugs kick on, this will actually send ground. So you need to hook up 12 volts to the other side of the light or the LED. And this side, pin 40 will be the ground side of the circuit. We've covered the cruise, MAF again, throttle, intake air, N75 throttle. We've covered brake. Okay, clutch switch. Your clutch switch, if you have a clutch switch in the vehicle, it's a good idea to wire it up. The CJ7 does not have a clutch switch. What it can do for you is if you're driving on cruise control, you push the clutch in, it loses the 12 volts and it disables cruise. In addition, if you push the clutch in with cruise on and you don't have a clutch switch, like I have in the CJ, the engine will over-rev a little bit, it'll realize what's happening, and it'll shut itself down. If you don't have cruise control, you still want to wire this up. If you do not wire this up, if you leave it blank or if it's missing because yours is an automatic vehicle and you don't want to take one of these other wires and toss it in, the first start, when you start it up and you give it accelerator pedal for the first time, it will fall down, meaning if you're going, I think it's like 2300 RPMs. It'll hit 2300 RPMs, and even though your pedal is depressed by your foot, the engine will fall down back to idle. As soon as you took your foot off the pedal and reapply the pedal, it'll work perfectly fine until you start the engine again. Shut it off and start it again. It'll always have that dead pedal for the first pedal press. After that, you're good to go. But if you hook it up to 12 volt ignition, the same way that you hook up the ignition wire, the fused wire, if you hook all those up to the same thing, the cruise control wire, it'll eliminate that. Again, MAF sensor, everything else down here, you'll see that other than the ignition we talked about before, it's all already wired up into the plug. You don't have to do anything unless you need to extend the wires. Let's go over here to the sensors. So the coolant sensor, you don't need to worry about 1 and 2 unless you're using the dash. That is specifically for the gauge. Everything else is pretty self-explanatory. The needle lift sensor and the crank position sensor are both shielded wires, meaning that the wires themselves have a metal shield around it. If you are doing a do-it-yourself harness, you need to tie these two shields together, and then you take that shield and you tie it into the third wire from the crank position sensor where it goes into pin 86. And I'll show that here in a second in the actual schematic. Injector pump is common sense. You have to hook up power and power. Ground, everything else is wired up. Map sensor, common sense, N75. You need to hook up to the 109. I power everything through the main input. I'll show that here in a second. MAF sensor, if you don't need it, remove it. Don't worry about it. Glow plug, if you're not going to use it, don't worry. Do it, do it how you have to do it. I do independently fuse this. I'll show that here in a second. Relay 109, if you're going to use it, great. If not, don't worry about it. OBD2 port. Again, these are the wires that I run, except for now I'm running the CAN bus high and low in the XJ swap. The pedal, this is kind of important. So the wires from the ECU into the blue connector, out of the blue connector, into the pedal can sometimes be different. So, for example, pin 2, which is pin 12 on the ECU, should be the same color. So we have yellow and green, and we have yellow and green. You'll see here with the rest of them, other than 3, they are different. So pin 1, which is pin 63, which is right here, shows white and blue. So it's white and blue coming from the ECU, going to gray and white into pin 1 on the pedal. Again, self-explanatory, take your time, you should have no issues with that. And I think that's about it for this. Alright, so this is the last part of this video. This is basically the schematic that we kind of talked to with the Excel. So I'll go step by step. I don't want to go too crazy because I'm sure you guys already know this. Alternator load sense wire, we don't have to worry about that. Ground, again, common sense. This ignition wake-up wire we were talking about, you type it into pin 88. This is basically my 109 circuit right here. So 12-volt ignition for these 3 wires, blue for the brake switch, red for the injection pump and the ECU, and yellow for the sensors. When reading this thing, it's quite simple. So we have on this first page, pin 9 of the ECU comes across to the second page, goes to number 2. Number 2 comes up and ties into the glow plug module, which is that big relay. Alright, so we'll continue down. So we have grounds, we have the CAN lines, we have cruise control, 12-volt ignition. That was when I was telling you guys you can delete if you want to. We have 16, which is the K line. Vehicle speed sensor, only needed for cruise control. Check engine light, I showed you the schematic for the transistor dual resistor you need to make. Tachometer, again, you're going to have to translate that from Volkswagen language to Toyota language or Jeep language or whatever you might be swapping into. That's not the law, but it's a rule of thumb. If it works, then great. If not, you need to translate that. Everything else is connected. Pin 40 is a glow plug light. Cruise control, as we talked before. Pin 44 is set. 45 is resume. 46 is on. Here is the pedal assembly we were talking about. Remember, although pin 3, what was the pin? Yeah, pin 3. So it comes from pin 50 on the ECU, goes into that blue connector, which is not the same as the pedal connector. So it goes into the blue connector in connector 4, and then it goes into the pedal 3. Doesn't make any sense why they couldn't have, numbered those the same, 1 to 1, 2 to 2, but for whatever reason, they chose not to. Alright, continue down. So in the glow plug trigger assembly, we have a ground. We have a 12-volt constant fuse. I 50 amp that circuit. We have 12-volt ignition that comes down to the brake light switch. Again, this is only for cruise control. I'm sorry, it also, if you have an automatic, it pulls timing, it pulls fuel when you hit the pedal so that the the injection pump is not pushing fuel when you've taken your foot off the accelerator in automatic. Hope that makes sense. Okay, so final page, this is the clutch wire I talked about, pin 66. If you have an automatic, that pin is not going to be there. You need to add that. Most, if not all tuners, all tuners do a manual tune. Otherwise, you have a bunch of code for the automatic, which is no longer going to exist into your swap vehicle. If you don't know, the EDC15 has, I think it is 3 different map sections. I think it's 3, yeah. So 1 for automatic, 1 for manual, and then 1 for four-wheel drive for the Boras that are overseas. The nice thing with that, like Techmetronics is a prime example, they can actually give you multiple maps, and they can hardwire into your ECU a switch. So you can have a tow tune, and if your switch is in the down position, you're in tow. And if you're not in your tow tune and you want to race someone or something like that, you flip the switch, and on the fly, it switches over to the second map configuration. So this is basically it. I did wire these pins. These are part of the injection pump. All these wires here, these yellow wires, are from the 109 relay, 109 circuit. So these are all part, wires you have to wire up. But again, this is wiring in a nutshell. It sounds overwhelming. I'm sure I talked way too fast, but you should have a general understanding. If you don't, as before, please feel free to post down below any questions that you have. I'll help you to the best of my ability. Again, I don't feel overly comfortable when it comes to the BHW or the BEW because I've never played with them. I don't know, this information that I have here is what I have gathered, but I have no way to verify that it's correct. All of these files can be found on the Facebook group TDI Swaps, not TDI Swapped Trucks. If you don't have Facebook, borrow Facebook from someone, answer the questions of the group. I'll let you in, take the files, do with them as you please, share them. I think this information is great for anyone who wants to save $1,000 in a harness that will work. There are too many horror stories where people spend that kind of money and their things don't work when they first get it. I'm speaking specifically about slow backwards. So again, if you have any questions, comments or concerns, please feel free to let me know. And I appreciate you watching the video to the end.